Hello everyone, welcome back to my channel Science Sutra. In this video, we are discussing the term called refractive index. Okay, in my last video, I gave a little hint about refractive index, right? When I was explaining, if you see my last video, you will get to know that I was explaining about the laws of refraction. In that, I explained the second law, that is Snell's law. How we can define the Snell's law as? It is defined as the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is always equal to a constant, and that constant we will call that as refractive index. Refractive index is generally denoted by the symbol N. Okay. Now, in this class today, we are knowing why we need to study the refractive index. Okay. As we all know, what is refraction? If I ask you, what you will answer? It is an optical phenomenon where the light ray, when it is traveling from one medium to the another, it undergoes refraction. Refraction in the sense there will be change in the direction of the light ray. See, if I want to write that diagrammatically, how I can represent refraction? This is medium 1 and this is medium 2, correct? See, when a light ray, if I take a light ray is entering, okay, and it is made to fall on the medium 1, okay. So, what happens when it is traveling from medium 1 to medium 2? It has to undergo refraction. So, you will see a change in the direction of the light ray. You may see the light ray can bend towards the normal or away from the normal. It all depends on whether the ray is traveling from rarer to denser or from denser to rarer. I explained that also, right? When a ray is traveling from rarer to denser, you will see the bending of light ray towards the normal. Correct? When this light ray is entering from denser to rarer medium, you have to take this light ray which has undergone the refraction. It has to bend away from the normal when it is traveling from denser to rarer medium. Correct? This is the phenomenon called refraction. See, if I take the medium 1, the light ray traveling in the medium 1 with a speed v1, right? And in the second medium, what happens? The light ray show a change in the direction as well as change in the speed of light, right? So I will take the speed to be v2. This refractive index is directly related to the speed of light traveling in different medium. Okay. But why we need to study this refractive index? If you ask me, I will answer in this way. The refractive index gives the amount of bending of light ray. Whether the light ray has bent with a small angle, or else whether the light ray has undergone more bending, or whether the light ray has seeing the angle of refraction to be greater, or whether it is showing a less angle of refraction. That value we will get to know by knowing the refractive index. It gives the amount of bending of light ray. Refractive index gives the amount of light ray that has bent when it is traveling from rarer to denser. Or else you can take denser to rarer. Or else you can take from medium 1 to medium 2. The refractive index, why we need to study the refractive index? It helps us to know about the amount of bending of a light ray. Okay, it helps to know whether the light ray has undergone less refraction or it has undergone a more refraction. That value will help us to know, okay, to know about the bending of light ray. Okay, for that purpose we have to study the refractive index. But this refractive index is again related to a physical quantity which we can measure, that is speed of light, right? As we know, when the light is showing some refraction, it has changed its speed value, right? When it is moving from rarer medium, it will have some value. When it is moving to in a denser medium, it will have some value, right? The speed of light differs when it is traveling from medium to another medium, right? So this refractive index, how we can relate the refractive index with the speed value, the speed of light. In order to explain that, I will take this figure, okay, where I am taking the medium 1 and medium 2. When a light ray is made to fall on the medium 1, it will show some refraction, correct? It will show some refraction where this represents the angle of incidence and this represents the angle of refraction. And in this case, you can take any medium like a rarer or denser denser to rarer. You can take any one, and I will take the speed of light in the medium 1 as V1 and the speed of light in the medium 2 as V2. Okay, and this represents the ray AB and this normal as N prime. So if I want to give the formula for the refractive index, I can define the refractive index as the speed of light ray in medium 1 to the speed of light ray in medium 2. So as we know, the speed of light in medium 1 is V1 and the speed of light in medium 2 is V2. See, if we are taking this is the value of refractive index, but we don't know with respect to what, right? This, if I write N21, that represents the refractive index of medium 2 with respect to medium 1 is equal to V1 by V2. Okay. So in the same way, we can write the refractive index of medium 1 with respect to medium 2 as we have to interchange these two values. So it will be equal to V2 by V1. This is the notation which is very much important. Okay. See, if I write N21, what that represents? N21 represents refractive index of medium 2 with respect to medium 1. And if I write N12, what that represents? The refractive index of medium 1 with respect to medium 2. Okay, this notation is important while writing the formulas. Okay, and if I take the medium 1, okay, if I take this is AB and this is N prime, this is O. If I take the medium 1 as air or vacuum, okay, and the medium 2, I will take like that only, medium 2, and if I take the medium 1 as air or vacuum, then we will call that kind of refractive index. The refractive index of the medium with respect to air or vacuum is called to be the absolute refractive index. What is absolute refractive index? It is the refractive index of the medium with respect to air or vacuum. The refractive index of the medium with respect to air or vacuum. The refractive index of the medium with respect to air or vacuum is called absolute refractive index. Refractive index, and we will denote that symbol as Nm. Okay, Nm represents the absolute refractive index. So how we can define the absolute refractive index? See, if I take the medium 1 as air or vacuum, I will consider the speed of light to be c. Okay, c represents the speed of light when it is traveling in air or vacuum. And if I take the medium 2 as it is, and I will consider the speed of light in this medium as v. So how we can define the absolute refractive index? Absolute refractive index is equal to speed of light in air or vacuum to the speed of light in the medium. This represents the absolute refractive index. So, if I give Nm is equal to C by V, what that represents? It represents the absolute refractive index, or else you can say the refractive index of the medium with respect to air or vacuum. Okay, this formula is important, okay, while solving some problems. And one more thing here, this in your textbook, the table 10.3, if you refer the table 10.3, they have given a series of refractive indices of certain mediums. Okay, if you see that, they have given NW value, they have given NG value, they have given NA value, so on. What this NW represents? NW is the refractive index of water with respect to what? With respect to air or vacuum. Like that we have to consider. It is refractive index of water with respect to air or vacuum. Simply if they have given like Ng, what that represents? That represents the refractive index of the glass medium with respect to air or vacuum. They have given a series of values, okay, of different mediums. If you want, you can go through that table. So you will get to know the refractive indices of the mediums will goes on increasing or it may decreases. Okay. Next, we have one more thing we have to do in this. Here, the refractive index of the kerosene is greater compared to the refractive index of water. So I will call NK, that is the refractive index of kerosene is 1.44 and it is called to be the optically denser medium. If the medium is having greater refractive index, then that medium we have to consider as optically denser. And here the kerosene is said to have, or it is called to be the optically denser than water, even though its mass density is small compared to water. Smaller, or if its mass density is less compared to the water, even though the case is like that, the optically denser medium here in this case is kerosene. Okay, the optical medium, what that represents? Optical medium, in a sense we have to take the optical medium as the ability of the medium or else you can take optical density. The optical density, what that means? The ability of the medium to refract light ray, that we will call as optical density, right? This optical density is different from the mass density. Don't get confused with optical density and mass density. Okay. And while we are explaining this concept, we are using the rarer and denser medium, right? What is rarer? The speed of light. If the speed of light is more, then that medium we will call as rarer medium. And if the speed of light is less, then we will call that medium as denser medium, right? It is not just rarer or denser. We have to say that as optically rarer medium and optically denser, like that we have to say. Okay, and by knowing these two values, what we can say? If the refractive index value is more, we will say that medium as optically denser, and if it is showing a less value, then we will call that as optically rarer medium. Okay, don't get confused with the optical density and the mass density. Yes, in the next Next, we had to know about refraction through lenses. Okay. See, before studying about the refraction, how the refraction phenomenon occurs in lenses, before that we need to know about what are lenses. Correct? I will give a definition. Okay. A transparent medium which consists of one or two spherical surfaces. That kind of medium are called to be lenses. Okay. A transparent medium means the medium that helps for the transmission or for the free flow of light. That kind of mediums are called to be the transparent medium, right? So a transparent medium which consists of one or two spherical surfaces, then that is called to be a lens. I will give an example here. You have to say whether it is a lens or not. If I give like this, do you call this as a lens? Yes, this is called to be a lens. Why? Because it has one spherical surface and one plane surface. This is plane surface and this is spherical surface, right? So I will call this as a lens, and this name of the lens is plano-convex lens. If I write the lens like this, do you call this as a lens? If I write the figure like this, do you call this as a lens? Yes. Why? Because it has one spherical surface and one plane surface. But here the refractive or here the facing will be different. Okay. So this is plano-concave lens. Okay. Here the reflecting surface is inwards. Okay. If the reflecting surface is outwards, then we will call that as convex, and if the reflecting surface is inwards, we will call that as concave. This is plano-concave lens. Okay. What about the convex and a concave lens? How it look like? You had to take this as a double convex lens, or else you can take simply convex lens. Okay. And one more, this is double concave lens, or you have to take that as concave lens. Okay, just simply you can take that as concave lens. Right? Lens is a transparent material where we can see one or two refracting surfaces or spherical surfaces. Okay. If I take a lens like this, okay, how many spherical surfaces you can see? If you draw this, how many spherical surfaces you can see? You can see two spherical surfaces, and each surface will have one center. Correct? So this C1 and C2 are called to be the center of curvature of the spherical surfaces. So how we can define the center of curvature? Center of curvature is called the center of the sphere of which the reflecting surface is a part. Okay. Here C1, C2 called to be the center of curvature. Correct? And C1, C2 what you will call? That is called to be the center of curvature, and how we can define the center of curvature as it is the center of the sphere of which the reflecting surface of which the reflecting surface is a part. Okay, that is called to be the center of curvature, and in the case of lenses we will see two centers of curvature because a lens is formed because of two spheres. And here an imaginary line passing through these two centers of curvature is called to be the principal axis. What is principal axis? Principal axis is the imaginary line that is passing through the two centers of curvature, that is C1 and C2. Next we need to know about aperture. What is aperture? See, if I take this, okay, what is this? This is the circle part of a sphere, right? The diameter of circular surface of the sphere is called to be the aperture. The diameter of the circular surface of or the circular faces of the lens is called to be the aperture. If this aperture is less than the radius of curvature, if the aperture or the diameter, you can say, if the aperture is less than radius of curvature, then you will call that kind of lenses. That lenses are called thin lenses. Okay, that lenses we will call as thin lenses. Okay, what is aperture? I hope you have understood. Aperture, this is the aperture. This is called to be the aperture, and this should be less compared to its radius of curvature. Okay, that kind of lenses are called to be the thin lenses. Okay, and this is about convex. If you want concave, you can write that also. That aperture, this part is called to be the aperture. Okay, this is called aperture and this is called aperture. Okay, next we need to know about the principal focus as well as the focal length. See, while explaining the mirrors, I explained about the principal focus, right? How we can determine that principal focus, right? For that we have one activity, same activity which we did or which we have learnt in the mirror case. For that we have to take a paper and we have to take a lens. What we have to do? We have to make this a lens such a way that we have to get a bright spot on the paper. What image you have to do? See through your naked eye. Okay, it may damage your eyes. Please be careful. Just what you have to do, you have to make the image of the sun to be seen on the paper. Okay, that what you have to do. After some time, if you bring or if you manage to bring the bright spot on the paper, it starts burning. Why it is so? The lens, the function of the lens, if I take this is a convex lens, the convex lens, what it will do? It will converge all the rays at one point. As a result, we are getting a bright spot. Bright spot in the sense it is the image of the sun itself. Because of the excess of concentration of the sun rays at one point, it starts burning. Okay. So, what we will get to know? This bright spot, how we will get to know or how we got this bright spot? The lens which we are taking, it converges, it makes the rays to meet at one point. Okay, and that point we will call as principal focus. This is principal focus. And how we will get to know the principal or focal length? By measuring the distance between the lens and that image is called to be the focal length. So, this is the focal length and this is principal focus. How you got the principal focus? By merging all the rays at one point. After refraction, by merging all the rays at one point, we will get one point. Now that point we will call as principal focus. Okay, and this is about principal focus and focal length. Now we need to know about converging lens and diverging lens. See, I will call convex as converging and concave as diverging. Why? Because I will write the diagram so you will get to know. This is a convex lens. Okay, it has two centers of curvature C1 and C2 and an imaginary line passing these two lines or passing through these 2 points is called principal axis. Correct? This is principal axis, and I had to consider parallel beam of light that is falling on this lens. And one more thing I have forgot, I want to explain about the optic center. See, each lens is said to have one center point, and that point we will call as optic center. This is the case of convex. You can take concave also. Even in concave you will see a central point. That point we will call as optic center. And whatever ray that you are directing to the optic center, it will just pass through that point without any deviation. You will not see any refraction or reflection if you are making the ray to pass through the optic center. Okay. If I take these parallel beams, after refraction what happens? Here you will not see any deviation. After refraction, it meets at one point, and that point I will take as F2. Since we are having two spherical surfaces, we will have two focal lengths also. So this is one foci and this is one foci, F1 and F2. Since the lens, convex lens, is making the rays to converge at one point, I will call the convex lens as converging lens. Okay, I hope you got the point, right? Why the convex lens is called converging? Because the parallel beam of light that is falling on the lens, it will make the rays to meet at one point, and that point we will call as principal focus. Okay, and if I want to talk about focal length, I need to measure the distance from optic center to the focal principal focus. That gives focal length. F1 or F2 you can take, and here you can take F1. So this is converging lens. Okay, what about diverging? Why it is called diverging? For that you have to take a concave lens. You have to take a concave lens, and what else you have to take? You have to consider two centers of curvature C1 and C2 and a straight line passing through these 2 points, correct? And it has one optic center. And if I take the rays, 2 parallel or 3 rays I will consider, one that is passing through the optic center. After refraction what happens? It will refract the ray in some other direction. It will diverge. It will change the direction of the light ray in this way. It will not make the point, or it will not make the refracted rays to converge at one point. It is diverging. It is making this rays to travel in different directions. So I will call this lens as diverging lens. Okay. See, if they ask you why the concave lens is called diverging, you have to write this diagram, then you have to explain. How you can explain? When the light rays is made to pass through a concave lens, it diverges the rays of the refraction, and hence they are called to be diverging lens. Okay. So this is about converging, diverging. Okay. And these are some of the terms, basic terms that you need to study in lenses before studying the refraction through lenses. How the image will be formed in lenses, that we need to study in the next class. Okay. And this is the basic terms which you need to know before studying the image formation in lenses. Okay. If you like this video, please like, share and subscribe to my channel. Thank you.